Hello, my name is Ken Schachter, and welcome to the C2000 Microcontroller One-Day Workshop. The objective of this workshop is to fully understand and gain a complete working knowledge of the C2000 microcontroller. This will be accomplished through detailed presentations and hands-on lab exercises. The workshop will start with the basic topics and progress to more advanced topics in a logical flow such that each topic and lab exercise builds on the previous one presented. At the end of the workshop, you should be confident in applying the skills learned in your product design. The outline for this workshop starts with an introduction covering the materials required and provides a brief overview of the C2000 product family. Next, we will look at the architectural details and discuss the block diagram, memory map, and peripherals. From there, we will move to the programming development environment and gain the basic skills needed to use Code Composer Studio, as well as learn about a linker command file. Then, we will have a lab exercise to practice the skills learned thus far. We will follow this with the peripheral register header files. At this point, we have covered the basic foundation. Next, we will dive into the device and learn about reset, interrupts, and system initialization. In this lab exercise, we will use the watchdog to generate a reset and interrupt, reinforcing what we have just learned. Then, we will cover the control peripherals, which includes the ADC, EPWM, eCapture, and EQEP. In this lab exercise, we will generate a PWM waveform, then feed it into the ADC and graph it using Code Composer Studio. Additionally, we will learn about the real-time mode emulation features. The next topic will be programming the flash. In this lab exercise, we will develop a complete embedded system using the code from the previous lab exercises. Finally, in the next step, we will discuss where you can find more information, allowing you to continue learning and exploring on your own. We will now start the workshop introduction. The materials required for this workshop are available at the link shown at the top of this slide. Please be sure that you have the F28069 control stick kit. The included jumper wire will be needed for the lab exercises. Make sure that you have all of the software installed. The lab directions are written based on Code Composer Studio version 5.1.1. The workshop installer will automatically install the lab files, solution files, workshop manual, and documentation. Texas Instruments' processing portfolio covers a wide range of embedded processors, from microcontrollers to ARM-based processors to digital signal processors. Our microcontrollers include the 16-bit ultra-low-power MSP430 microcontroller family and the 32-bit real-time C2000 microcontroller family. Our ARM-based processors include the 32-bit ARM Cortex-M3 Stellaris microcontroller family, the ARM Cortex-A8 Satara microprocessor family, and it also includes the OMAP devices, which incorporates a C6000 and ARM processor. Our digital signal processors include the C6000 DaVinci, as well as multi-core DSPs with up to 24 billion multiply accumulates per second. Additionally, there's an ultra-low-power C5000 digital signal processor family. The C2000 family, which this workshop is based on, includes the Piccolo, Delfino, and Concerto product lines. The Piccolo product line ranges in performance from 40 MHz to 80 MHz and has options for a floating point unit, control-law accelerated coprocessor, a Viterbi complex math CRC unit, and USB. The Delfino product line ranges in performance from 100 MHz to 300 MHz and features a floating point unit and some devices with an external memory interface. The Concerto product line consists of a dual subsystem architecture incorporating a C28X CPU with performance up to 150 MHz and an ARM Cortex-M3 CPU with performance up to 100 MHz. In addition to floating point capabilities, it has a Viterbi complex math CRC unit. The three product lines provide you with over 150 devices to choose from and maintain software compatibility. The C2000 product family has a very broad application base with target markets in motor control, lighting, smart grid and power line communications, automotive, digital power, and renewable energy. When comparing the Delfino and Piccolo product lines, you will notice that the Piccolo F2806X devices share many features with the Delfino product line. The Delfino product line is shown in the table by the F2833X column. Therefore, the F28069, being the most feature-rich Piccolo device, was chosen as the platform for this workshop. The knowledge learned from this device will be applicable to all C2000 product lines. The development tool for this workshop will be the TMS 320 F28069 control stick kit. This control stick is a self-contained system that plugs into a free USB port on your computer. The USB port provides power as well as communicates to the onboard JTAG emulation controller. LED LD1 illuminates when the board is powered, and LED LD2 is tied to GPIO 34. We will be using this LED as a visual indicator during the lab exercises. Some of the I/O lines from the F28069 device are pinned out to the peripheral header. We will be using the included jumper wire to connect various I/O lines on this header.